Hi, this is Jason Molesky. In this example, we'll take a look at calculating a confidence interval for the slope of the true regression line. Now, everyone knows that cars and trucks lose value the more they're driven. What we want to know is, can we predict the price of a used Ford F-150 Super Crew 4x4 if we know how many miles it has on the odometer? Now, suppose a random sample of 16 used Ford F-150s was selected from among those listed for sale on Autotrader.com. The number of miles driven and the price in dollars were recorded for each of the trucks, and we see in this table we have the miles driven and the price in dollars for those trucks from Autotrader.com. Now here we see a scatter plot of that data, and we note there is a negative linear trend. As miles driven increases, it appears price decreases. When we look at the residuals, we do see a bit of a random scatter around the residual equals zero line. And in our histogram, we note that we do have a unimodal, single-peaked, somewhat symmetric distribution here. Now we also have the Minitab output here, and we'll use that to construct and interpret a 90% confidence interval for the slope of the population regression line after we check to see if the conditions are met. So before we do that, we'll note that the estimated slope in this case is negative 0.16292, and the standard error of our slope is 0.03. Now we're going to use those two to calculate the confidence interval again after we check if the conditions are met. Now we'll use our LINER acronym to help us remember which ones to check. So L for linear. We note the scatter plot shows a clear linear pattern. Also, that residual plot showed a random scatter of points around that residual equals zero line. I for independent. Because we sampled without replacement to get the data, there have to be at least 160 used Ford F-150s listed for sale on Autotrader.com. We'll assume that condition is met. N for normal. The histogram of the residuals is roughly symmetric and single-peaked, as we saw, so there are no obvious departures from normality. E means we check for equal standard deviations or equal variance, and the scatter of points around the residual equals zero line appeared to be about the same at all the x values. Finally, R for random. Note we randomly selected the 16 pickup trucks in the sample. So because those conditions are met, we'll use the t-distribution with 16 minus 2, or 14 degrees of freedom, to find the critical value. Looking that up on the table, we find that for a 90% confidence interval, the critical value is t star equals 1.761. So our 90% confidence interval for the true slope beta is our observed slope plus and minus the critical t times the standard error of the slope. From the Minitab output, again, our observed slope was negative 0.16, and our standard error was 0.03. Performing the calculations, we end up with a 90% confidence interval from negative 0.21, or as negative 0.22, to negative 0.11. So we're 90% confident that that interval from negative 0.22 to negative 0.11 captures the slope of the population regression line, relating miles driven to price for used Ford F-150 Super Crew 4x4s listed for sale on Autotrader.com. For some additional practice in calculating and interpreting a confidence interval for the true slope of the regression line, try exercise 9.